Greetings, my name is Michael Cook. I'm an application developer, design artist, and system engineer. In this particular video, I'm going to be covering a document that I've put together regarding FEInfrastructure, the utility that I put together a couple years ago. Let me put this in the full screen. So, FEInfrastructure, 11/21/2023, introduction. In this document, I'm going to cover a video that I recorded almost 2 years ago, which was a demonstration of the function new FEInfrastructure, which is part of the module FightingEntropy. Seeing as how I was recently injured in a felony hit and run on October 9, 2023 in the town of Clifton Park, New York, at about 9:15 p.m., Clifton Park Center Road, 599 Clifton Park Center Road, and how my elbow was fractured in 4 places, which required surgery, and I've been slowly recovering my ability to use my left hand to type stuff. I haven't updated the module for some time, partly because of the injury, but also because of the stresses of working on Get ViperBomb and Invoke SimDB. Get ViperBomb is meant to help automate the configuration of a machine's services, event logs, application, AppX applications and packages, system settings, and other stuff related to system management and even desired state configuration and Windows features. Both of these utilities are core components of the module, although Invoke SimDB is more of a conceptualization of merging a CRM client relationship module with a front end to an SQL database and even Active Directory domain services. Regardless, there are plenty of things I know I need to work on and update in the module. And by the way, if I haven't mentioned it, it's particularly targeted for Windows environment, Windows 10 and up, and also Windows Server. Regardless, there are plenty of things I know I need to work on and update in the module. There are many things I'd like to finish working on in the function new FEInfrastructure, which is meant to automate imaging, virtualization, installation, and configuration of operating systems for servers and desktop clients for a computer network, network of computers, or network of networks of computers. And although this function does not currently install Linux, Unix, or FreeBSD, it will eventually cover those operating systems and their various derivatives and distributions. Currently, new VM controller does make accommodations to install Linux, Unix, and FreeBSD on virtual machines straight from an installation image. I made multiple videos of that earlier this year. And it also contains functionality to automatically generate or map out an entire virtual network, DHCP scopes and options, DNS pointers, and managed credentials that can interact with an existing Active Directory domain. I've made many videos that feature new VM controller, as I just specified, but it is just a much smaller version of new FEInfrastructure that has newer features, controls, and login capabilities. As for the function new FEInfrastructure, it effectively shoestrings a number of components and services on a Windows Server 2016 and up instance, such as domain name service, dynamic host control protocol, ADDS, Active Directory domain services, Internet Information Services, Windows Deployment Service, Microsoft Deployment Toolkit, Windows Assessment and Deployment Kit, Windows Pre-Installation Environment, Deployment and Image Service Module, Veridian or Hyper-V to perform the above tasks. However, being able to fully update that would require a decent workstation with hardware that would allow me to virtualize multiple systems and to test these things in a fully functional Active Directory domain. The above video link leads to the previous iteration of the new FEInfrastructure function that was running on a Dell PowerEdge R410 from 2009. The machine is from 2009, not the function I wrote. Here is an extended description of what is happening in that video. Description. 0 seconds. Megadeth, piece sells, but who's buying begins to play, with the header stating preview demo featuring FightingEntropy, new FEInfrastructure PowerShell deployment, and FEWizard. Basically, the demonstration covers those 3 things. Estimated time 120 minutes. 14 seconds in, switching the scene to the local laptop, minimizing OBS, switching to remote desktop protocol over customized virtual private network tunnel from to 10 Aiken Street, Johnstown, New York 12095, the 201D Avenue Circle, Clifton Park, New York 12065. 27 seconds in, highlighting and overloading the function to flush the module from my GitHub repository at github.com/mcc85s/FightingEntropy. Flushing the module means to remove all traces of my work and then to reinstall all the prerequisites to perform the process seen in the video. It is not all that dissimilar from taking a bomb and exploding my car, but then having all the parts necessary to rebuild it all arrive at the same time, so I can immediately rebuild it and drive where I gotta go. This is important because the module is meant to be able to distribute the module the module is meant to be able to distribute itself to all of the child item computers that the function is actually preparing. 31 seconds in, executing the function that was just loaded in memory, which flushes the module using a previous version of FightingEntropy 2021.10.0. The newest installation method is exponentially faster than this because everything is compartmentalized into a zip file, and then the function sort of calculates what's the correct hash, and if it's not the correct hash, then it'll download the correct files and stuff, but that still requires access to the internet to verify. I'm still working on a way to conceptualize doing this offline. 129. Once the module is reinstalled, the PowerShell host displays information about the module, author, company, registry path, resource path, classes, functions, and etc. The new versions, 2022.10.1 and up, some no longer available, are a bit more compact and extensible, as I created a class called Module Controller, which has so much additional functionality in relation to regenerating the module and manifest, the logging, writing the console, dumping the console to file, writing stuff to file, writing stuff to registry, accessing files like controls, graphics, and functions, and being portable enough to use within other components of the module, and not needing like many seconds to pull itself into memory. In other words, the module controller provides much more granular control than the iterations seen in this video, and I've yet to implement these changes into the function new FEInfrastructure and then demonstrate how much work it does to manage system administration and network resources, as well as to provide evidence that I'm a solutions architect and a security engineer, in addition to a slew of other titles and roles. 1 minute 33 seconds. Then I call module equals get FE module, which automatically imports the module into memory because the module is now part of installed modules. Doing so actually uses the function write theme to display in the console loaded module FightingEntropy 2021.10.0 in a cool green, blue, and white themed message box in the console. This is a signature of how detail-oriented I am about writing things to the console. 1 minute 47 seconds after declaring module, the variable module I then entered into the console to get the loaded information back, which shows similar information to when the module was installed with the function flush module, which is just like a couple of lines. It's not a fully legit portion of the module. It was just meant to show that I was erasing it and then reinstalling it. By the way, the Viridian Hyper-V window is seen to the right of the Visual Studio Code window, which shows a number of virtual machines that I had already had on the Dell PowerEdge R410 server, running Windows Server 2016, I believe. 1 minute 57 seconds, and then call new FEInfrastructure, which is the custom function being featured, which loads and says initializing an infrastructure deployment system. And then a XAML-based graphical user interface that I designed myself in Visual Studio called Get FEAD Login pops up on the screen. 1 minute 59 seconds in, what can be seen in this interface is a login panel. Login, access Active Directory resources, username, password, and confirm, as well as a dialog box that shows information for a domain controller that was found, its IP address, DNS name, the domain, and NetBIOS info. It also contains a text box for manual entry and even provides an option to change the login port from 389, or you can enter 636 for LDAP SSL, or a custom port, although that needs to be fleshed out. This GUI is seen in the demonstration multiple times, and what it does is it accesses a component of Active Directory called the Directory Searcher object in order to validate whether or not the credentials entered into the login panel are accurate and legitimate. This is important because if the login information fails to successfully log into Active Directory, then the rest of the process will fail. I've yet to add additional functionality to show the graphics that validate the entries and prevent a user from failing to completely enter the required information. 2 minutes and 2 seconds, I then enter root at securitydigitsplus.com, which acted as a hybrid servicing and main admin account for the domain controller dsc0.securitydigitsplus.com, and a 16-character password with complexity requirements in the password and confirm password boxes. The password boxes themselves don't have that complexity requirement. The group policy on that server had that. Selecting one of the items in the data grid would have populated the server name box with that information, but I was having a conflict with that information since the server had dual network interface cards on the same network, originally meant for link aggregation, so I entered the alternate address manually. 2 minutes and 26 seconds, at which point the login was successful, and so the function began to collect information about the server in a similar manner to how the newer version of the module does, accessing WMI, Windows Management Instrumentation, and get SIM instance information like operating system, disk, network, processor, computer, UUID, motherboard, firmware, chassis, architecture, all now a part of get FE system and get ViperBomb. 235. Then the function collects the current IP configuration, DHCP information, DNS zones and records, Active Directory domain nodes, organizational units, sites, computers, users, Meridian info, WES info, MDT, WinPE, Win80K info, as well as IIS. This information falls under a property of the main controller class to further manage all of those services. 301. Then it loads the US postal code database, which is a part of the module, which allows which allows zip codes to be entered into potential sites and services topology. So if a network existed in 120.65, then the domain name for that zip code, state, and town would be automatically generated. So for instance, cp.ny.us.120.65.domain name. Whatever. That nomenclature there. Then it loads the controllers for the site list, network list, site map, ADS controller, VM controller. It loads all the existing nodes for the VM controller, meaning that all of those virtual machines that have a VMX or VMDK file that are in the Hyper-V hypervisor will be targeted and templatized into the interface for management, including the file sizes for each item found. Then it loads the image controller, which is meant to locate ISO files to be used for WIM file extraction. The image controller has been updated since then to accommodate non-Windows images. It also loads the update controller, which is meant to interface with files found through Windows Server Update Services, WSUS, or in a target path, so that each update file found can be processed and show its content in the interface. Lastly, before the FEInfrastructure GUI is loaded, which I also made, the MDT controller loads all of the MDT shares, persistent drives, and WIM files so that each MDT deployment share can be managed via the GUI. Well, it also loads the WDS controller, which interacts with the WDS service to load PXE boot images into the service seamlessly. 331, at which point this message appears, initialize infrastructure deployment system. 337, and then the graphical user interface for FEInfrastructure is loaded, infrastructure deployment system. Infrastructure deployment system. 337, this contains multiple tabs that control all aspects of the components I've just specified. The module shows the same information that was seen in the console about the module, as well as the files within the module. Config shows information about what was collected from the server and has subtabs like role, system, network, DHCP, DNS, active, ADDS, Hyper-V, WDS, MDT, Win80K, WinPE, and IIS. I'm not going to cover each subtab because it is a lot of information and it's rather self-explanatory. Domain shows information about the domain, allows entry of the organization name and the common name, as well as zip code entries to manage desired zip codes and domain labels that follow the nomenclature that I've specified above. This also validates the existence of potential distinguished names of sites and service links. Maybe this one does. Network establishes the IP subnet ranges to pre-allocate potential items for ADDS authorization, Active Directory Domain Services authorization. Sitemap allows the domain sites and subnets into a single object in order to manage site links. So when it combines the information from that tab and that tab, it creates this, and it creates a site and service, and then it attaches the IP subnet host range to that site link. ADDS manages all the nodes within a particular unique site link to automate the creation of gateways, servers, workstations, users, and service accounts. This part is critical because it combines all the information from the site links in order to propagate the ADDS information into the VM controller nodes. Virtual, basically a much more complex version of a new VM controller, which allows management of virtual gateways, switches, servers, and workstations. Imaging manages installation images in WIM file extraction via deployment and image servicing module for MDT shared generation. Updates manages Windows updates to implement packages into WIM files, effectively slipstreaming Windows updates into the installation image rather than to download the updates after the installation takes place. This would effectively reduce bandwidth needs upon post-installation. not complete or implemented. It's just there as an idea to expand upon at a later date. Share manages the entire process of the Microsoft Deployment Toolkit share creation. That's a joke. Which allows the implementation of PowerShell deployment by Michael T. Nyhouse, Johan Arwegmark, Michael Nystrom, Jordan Benzing, Zoopman, and the rest of the guys at Friends of MDT. It's actually called the Microsoft Deployment Toolkit, but I would imagine that they would occasionally refer to it as the Microsoft Deployment Toolkit, since the guy who came up with it, his name is Michael. Ha 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 ha. Anyway, there's a lot of stuff happening from here on out, so I won't be so specific about every little detail seen in the video. Though there are parts where the action is stagnant, even though the system is busy doing stuff, it's all been orchestrated in this process. 338. Starting on the module tab, there is information about the module, such as the GitHub repository, the author that went insane making this entire thing, joking, and the company he started to focus on all the things seen in this video. A ridiculous description about fighting ID theft and cybercrime or whatever, and the installation date, which shows exactly when the flush module completed installing the components of the module seen in the lower data grid. 340. Then I click on the config tab and roll through all the information that was collected from the server, all necessary to automate the process. After this dialog has built a new PXE image for WDS to deploy an installation via the PSD shares and the FE wizard dialog in the PXE environment. 410. I then click on the domain tab to enter the company name and the common name, which would be part of a security certificate once I complete the distribution method, whereby allowing something like Let's Encrypt on an OpenSense gateway properly configured with the top-level domain provider API keys, such as GoDaddy or Cloudflare or Google, whatever it's called, to enable SSL secure socket layer connections to other nodes in the topology domain, either internally or externally, for visiting websites and IIS and things of that nature. Well, eventually the PSD/MDT shares will be able to leverage HTTP/HTTPS rather than SMB, theoretically reducing the operating system installation time with something like branch cache or whatever it's called. Friends of MDT has something called the hydration kit, and I think that they have something in relation to branch cache, which leverages the HTTPS protocol instead of SMB. Haven't gotten to that point. It also has a field for zip code entry, which automatically generates unique domain names so that the gateways will be able to interface with Active Directory regardless of whether they are FreeBSD based or otherwise. As it does this, it will allow validation of an existing site name or to create, delete, refresh them. 438. Then I click on the network tab to determine what DHCP scope should be for that particular site link. I use the string notation format that is similar to that of OpenSense, like 172.16.0.0/19, which provides a range from 172.16.0.0 to 172.16.31.255, with the first address being the network address and the last address being the broadcast address. Providing the range in string notation is pretty important because it doesn't have to create 8,192 objects in memory, it just creates one. This information is meant to be propagated to potential DHCP servers. At some point, it'll also have reservations and stuff, which is something that I implemented in new VM controller. Although also this area allows the management/validation of existing entries or to create, delete, or refresh them. 459. Then I click on the site map tab, which allows an admin to create a site link, as well as select whether or not they want to create a multiple gateway or gateway, server or servers, computer or computers, user or users, or a or multiple service accounts. It also allows for validation of those objects being organizational units. The information here allows for the previous tabs to compile the template objects, and the objects just get bigger and bigger as they're processed from one tab to the next until the virtual tab. 512. Then I click on the ADDS tab, which populates some of the information depending on the selected site link name. This information is used to create potential objects on either a single basis or multiple. So if you wanted to create an array of these objects, then this is where the automation task would start to pay off rather than having to individually handcraft them for import into Active Directory. 516. Since I wasn't creating gateway servers, users, or service accounts, gateways, servers, users, or service accounts, I only selected workstation, and then I imported an existing text file named ws-112.65.txt with the Windows Forms open file dialog box, which automatically loaded that file into memory, and with that file it was able to create an array of workstation object templates, all of which already existed as a virtual machine in the Hyper-V window. The aggregate data grid was populated in this process and injected the template objects. I then clicked the Get button, which populated the output data grid, and selecting a particular object in that box shows the individual properties of those templates below. 550. By clicking Remove, I was able to remove those existing entries from Active Directory, though the actual workstations themselves still exist in the hypervisor. 556. By clicking New, it was able to recreate those objects, albeit with a brand new GUID for each item. 6 minutes. Then I click on the virtual tab and begin to play around with the objects that were already created, as the interface allows for me to delete existing virtual machines that match the newly generated ADDS nodes. Clicking the Delete Existing Nodes button brings up a confirmation box. Warning, are you sure? This is important because in the wrong hands, some idiot could actually remove a lot of existing virtual machines, and you don't want that. But in the right hands, idle hands are the devil's plaything, and thus I went ahead and committed to deletion, which then interfaces with Hyper-V and removes each individual workstation, its VMDK and VMX files, and relinquishes their existence, though I think it actually interacts with WMI rather than Hyper-V, and then Hyper-V just pulls from WMI or updates from WMI. Relinquishing their existence is a rather dramatic way to say deleting all traces of each virtual machine, but it's accurate. Probably sounds mean, but the thing is, after all the verbose output shows in the console, the tool allows me to recreate them as well as to configure them with the proper settings that I want each virtual machine to have, like RAM, hard disk drive size, generation 1 or 2, CPU cores, and type. 617. The type selected is network, which will leverage the WDS MDT installation method. The path will be the file path where the virtual desktop infrastructure will place all the machines. The image, when available, looks for the ISO file to use to create the virtual machines. The script is something that I've been working on with new VM Controller, where a script can be loaded to configure the machine from the server, be it PowerShell Direct or from the workstation itself, once it has fully installed the operating system and is ready to process things similar to a post-install sequence. But also, like, since the whole entire idea behind this VM controller is that it can use WMI to access the virtual keyboard and then enter in a script that way. But I also came up with an alternative method called Start TCP Session, which opens a TCP session and then it can send over a script that way. Yeah, so I don't know. A lot of this stuff is still, I don't know, as I've been developing stuff, I sort of mull over whether I want to include something or remove it, but I figure if I leave something and I don't develop something for it, then I'll leave it at that rather than have to go back and then implement something that I wanted to, that I didn't design from the ground up with that in mind. So basically, if I design something, I'll have a path where if I have an idea, I'll start out with it, but I may not fully develop it, and so the property will still be in one of the classes, but I might not actually need to proceed with that since I found another method. Anyway, 622, then clicking Get will validate whether the function can proceed, and then clicking New will actually go right ahead and then create the virtual machines via the combined template objects that the last 5 main tabs combined, all according to the specifications that were selected with the GUI. Complete. Virtual infrastructure deployed. Installation can begin. 652, then I click on the imaging tab, but I'm not quite ready to use it. 655, I pass right over the updates tab for now and went to the share tab. This is where the magic starts to happen. In the top data grid is a single share named FE001 with the corresponding properties for the type, root file system path, share name, and description, though some of this stuff will automatically populate. I scroll through the existing MDT share properties, which shows information similar to that of the Microsoft Deployment Toolkit. 701. Then I click on the minus button, which loads a prompt that says, warning, proceed. This will remove the share FE001. Of course, we want to remove it, and so I click yes, which then provides all of the verbose output, eliminating all the files in that share, and once it's done, it says remove persistent drive FE001. 712. When it does, it removes the object from the data grid and clears all the information from the GUI panel pertaining to that drive and share. At some point, the newer version of the module will have all this verbose output saved to the module controller or console object, but for right now, it's just using the native verbose switch to produce the information in the console. Since there's no drive selected in the data grid, portions of the GUI are disabled and grayed out, which prevents a user from entering information before a known existing drive and share is selected. We'll come back to this tab in a little bit. 714. Then I click on the imaging tab, which allows for the entry of an image path. So clicking select opens a Windows Forms folder browser dialog box, to which I select the folder that has all of the ISO files that I want to use to extract WIN files for a new MDT share or persistent drive. 724. Once the folder is selected, the function imports all of the ISO files in it so that I can select which ones I want to extract the WIN files from. 728. The first image that I select is Win10 21 h2 _ English _ x64.iso, which is the standard installation image for Windows 10 from the second half of 2021. Then I click Mount, which accesses DISM to show the content of that image. This process takes a few seconds because of the age of the machine, but when it comes up, it processes each found WIN file into an object that has an addition, expanded size, as well as the architecture and a label or tag. We're shooting to eliminate as many assumptions as possible in creating the desired output, and thus selecting the additions I'd like to extract allows me to create a WIN file extraction queue object, as the process isn't going to extract the WIN files until all of the desired images are in the queue. This process is important because we'll see the selected images in the FE Wizard tool with the PXE environment within the PXE environment after MDT updates the boot image, which can't be done quite yet because no MDT shares currently exist. As in the demonstration, I eliminated it, the one that did. 755. After creating the queue object of desired selected indexes, I clicked the dismount button, which removed the ISO from view, and this cleared the image viewer data grid. I then repeat this process for Windows 10 Enterprise as well as Windows Server 2019, 2022 data center editions, respectively. 838. Then clicking the select button opened another Windows Forms folder browser dialog box for DISM to extract the WIN files to. Once that was selected, I clicked on extract, which procedurally loads each of those ISO files and properly extracts the image to a folder with the same name as the tag that will be used to import into the MDT share. This process took 8 minutes, from 8:50 to 13:22. So here's a little bit of PowerShell code to come up with 4 minutes 32 seconds. 4 minutes and 32 seconds on an old Dell PowerEdge R410 to extract 5 different images. It's not bad. A newer system could probably do that in half the time or a quarter of the time, maybe even less. The 1325. Anyway, then I click on the Updates tab just to show up what I conceptualized. I clicked on Path, which opens another folder browser dialog box, and then I selected a path to where I had downloaded a few downloaded Microsoft Update files, MSU files, I believe, and the function used a native Windows executable to extract pertinent information about each update, not unlike how the Microsoft Update catalog does, or Windows Server Update Services. I believe it does that as well. Once all of those files were processed, the aggregate data grid lists each component, and selecting any of these components allows each object to populate the viewer data grid. At some point, this panel will allow these updates to be slipstreamed into the installation images. However, that process is rather lengthy, especially if there are multiple WIN files and additions. To convey the sentiment, I then type in "not yet implemented" into the text box for the WIN file path, because more thought needs to go into how to properly allocate the correct updates for the correct WIN files. 1436. Then I select the Share tab again. I clicked on the type and dragged the combo box down to PSD, which will install the necessary files to deploy a PowerShell deployment share. And then I clicked the root button, which opens another folder browser dialog. This is a little tricky because you want to select a path that has no existing files in it. I created a new folder named Flight Test, basically the same as before, at which point everything is needed to spin up a new MDT persistent drive. 1455. By clicking on the plus button, the necessary prerequisites for creating a new share are generated, such as a Samba share and a PS drive. MDT has a module file that will deploy all the necessary files to that location, but since PSD was selected, the function new FEInfrastructure has to also copy the files necessary to install the PSD deployment method. In this process, the correct templates are copied from the FE module control path. It also unblocks all the PSD files and shows the verbose output as it does this. Once the share exists, the console says success, added persistent drive FE001, though it'll change like the regular DS001. The more persistent drives you add, it's going to increment that number. And the data grid has a new item in it. When selected, populates the corresponding dialog boxes for the MDT drive properties. 1515, clicking on branding, all the boxes are empty, but since the server has all the necessary registry paths filled out, clicking on collect will retrieve those values to propagate to child items created via the MDT share. Clicking the apply button ensures that those values are committed to being processed. 1521, excuse me, clicking the local tab, the local administrator information is blank. Filling out the username, password, and confirm boxes allows the post-installation process to utilize that information. Clicking apply ensures that those values are committed to being processed. 1534, clicking the domain tab, we can fill out the information manually, or clicking on login allows the get FEAD login function to load again, allowing for another account to be used to deploy potential operating systems. I entered in FightingEntropy at securityplus.com as well as another 16-character password with complexity requirements in place. In the domain through group policy, not in the actual GUI. 1607, clicking on machine OU brings up an organizational unit browser, and selecting the correct one ensures that the bootstrap INI/custom settings the INI files receive the correct place to put in the new computer. Clicking apply ensures that those values are committed to being processed. 1614, clicking the OS TS tab and going to import subtab allows entering in the path where the WIM files were extracted, and then those items are imported into the import browser data grid. The files are not yet imported to the share, but by clicking on the import button, it allows them to be copied if the combo box says copy, which takes longer, or to move them if it says move, which is much shorter. But then you got to recreate those files if you do that and you delete them. 1632, clicking on import actually imports the WIM file into an operating system object, but it also creates a standard task sequence object. Well, actually, it's a custom task sequence object that installs FightingEntropy, which means that right out of the box, the boot images just need to be processed. This might not be the most suitable thing if a particular administrator wants to add additional processes or task sequences, but the post-installation process will make accommodations to further sculpt out the desired state configuration of each system, and that's ultimately what Get ViperBomb will do. Anyway, now that all of the operating system and task sequences are imported into this brand new share, the current subtab will show them with a label, name, description, and version. All pretty important as they each need to be unique. 1649, clicking on the config subtab, the bootstrap subtab has very little information in it. And yes, the content of the dialog box points to the file that the process created when it generated the share, the bootstrap INI. There's not much in it, but by clicking generate, it will pull all the information that was committed that was committed earlier into the bootstrap INI file text box. Clicking apply ensures that those values are committed to being processed into the bootstrap INI file itself. So the text box is just a representation of what's in the actual file, but clicking apply just saves it to the actual file in the file system. I hope that makes sense. 1654, clicking on the custom subtab repeats a similar process with more information pertaining to fields that the bootstrap INI file does not cover. Clicking generate inserts the proper information into the custom settings.ini file text box. Clicking on apply ensures that those values are committed to being processed into the custom settings.ini file itself. Writes it to disk. 1659, clicking on the post subtab handles all the things that someone will want to do as a post-installation criteria that someone will want to do as post-installation criteria in PowerShell. Currently, the information to install FightingEntropy is there, but this will require an internet connection, and the current code will not work because the module has been updated to a large degree as the version featured in the video is no longer existent. However, the module could indeed be localized, and that was a major concern when I developed the newer version of the module, 2022.10.1. It also contains the information needed to import the CSV file that has additional information to inject the graphics and company information into the system, the registry. Though this part may be replaced in entirety since the module will have a feature that does this via Get ViperBomb. Clicking apply ensures that those values are committed to being processed into the install FightingEntropy.ps1 file itself. So this script will wind up installing FightingEntropy, but it will also add in various other things that a PowerShell script that someone would want to do with a PowerShell script. 1704. Lastly, clicking on the key subtab allows the dskey.csv that I just specified to be generated and put into the path that the PostScript targets. Clicking on generate will create the customized CSV file, and clicking apply will write those values to the dskey.csv file itself. At this point, the combo box has at the bottom has the full option selected, meaning it's going to create the entire boot image that will be submitted to WDS for processing. Clicking update kickstarts the MDT deployment shared boot image creation process. And this part takes a while, about 15 minutes. 14 minutes and 56 seconds, which would probably take a lot less time on a faster system. At 3207, the boot image is automatically handed off to the WDS service, and it says updated MDT deployment share FE001. This takes about a minute, and then the dialog box for the FEInfrastructure system can be closed. So, virtualization. 3256, at this point, the utility has primed all the prerequisites for the installation to proceed. And now I spend a couple of minutes staging the virtualization lab, which effectively does many of the same things as new VM controller. 33 minutes and 33 seconds, a dialog box shows up to allow login credentials to be used for the post-installation process, which is the same information as in the beginning. I just hadn't made it part of the same process since the function new FEInfrastructure was all self-contained. This part of the process is focused on orchestrating one of the virtual machines itself to utilize the PXE environment and allow me to navigate the FE Wizard GUI, which kickstarts the PSD installation method. This was all very experimental when I recorded this, and to be perfectly honest, this part takes a very long time on this system, seeing it as it is a rather old Dell PowerEdge R410. I had to take a step back from continuing to test with the setup because of how many hours I was dumping into starting everything over from scratch, and the system just wasn't able to allow me to test the environment in a much faster manner. Prior to recording this particular video, I had made some changes that prevented the written process from working, mainly because of the underscore in the image tag. So I just made changes like live while recording the video. I wouldn't typically do that, but I had already committed to making it that far. Anyway, log.tx initializing workstation was just a message indication, but the newer version of the module will allow the embedded console tracker to do that instead. Currently, the current version of the module allows this to be a portion of the module itself. So when I call get FE module and save it to a variable like module, I can use module.update, and it will write something to the console and save it to the console, much like a transcription would. Like start transcription would. 3523, reset VM lab just initiates the object from file. The file was created by this in a certain location, and as the function new FEInfrastructure deployed files to disk that allow the virtual machine to be instantiated and controlled from the file system object. And since this process was crashing quite a lot and eliminating my ability to use things in memory or to debug or diagnose what was happening in each iteration. 3529, once the virtual machine is on, it immediately goes to negotiate the DHCP PXE process. 3542, previous versions of the boot image were seen in WDS. The process actually looked for the proper index to tell the virtual keyboard how many times it hit the down button to select the brand new image. 3553, the virtual machine is directed to the proper boot image, and WDS transfers that boot image. Now, I don't know why Megadeth, My Last Words, wasn't on the playlist that I had running, because that's a really awesome song, but after Wake Up Dead played for a second time, I decided to switch the music to Iron Maiden Greatest Hits Volume 1, which is no longer available. But that's okay. Megadeth and Iron Maiden are two really awesome bands. Side point. 3655, once the boot image is loaded, the PXE environment is then loaded. 3705, and this is where all of the modifications I've made to the PSD scripts begins to be seen by the executable that controls everything displayed in the background. Also notice the Security Plus LLC background. It takes a moment to load up the GUI, and all of the messages seen under progress were things that I either edited or kept the same in order to load the FE Wizard GUI. This GUI was something that I thought of back in 2019 when I ran across Damien Van Robay's PowerShell Wizard. I had to learn how to write with XAML and do it with PowerShell in order to get around needing to do stuff with the wizard.hta hypertext application that is part of the native MDT process. I also had to make sure that if MDT was selected, that it would only modify certain aspects of that method. 3901, get FE Wizard. In this graphical user interface that I also made in Visual Studio, there are tabs: local, keyboard, language, time zone, secondary keyboard, product key, etc. Root, task sequence selection, applications, drivers, packages, profile, extended shares, etc. System information, system name, password, hard drives. Domain, organization, OU, homepage, domain username, and network information. Control, domain plus NetBIOS, installation mode, new, refresh, virtualize, devirtualize, and backup restore information. In the local tab, certain things are required, like the keyboard and the time zone, and even the product key. But because this is a test system, we're not using a product key. 3922. In the root tab, you're able to select what task sequence you want to use, in addition to selecting applications, drivers, and all that other stuff that I wasn't primarily focused on demonstrating, since this was all relatively uncharted territory for me. 3941. In the system tab, you're able to change the system name, which isn't fully implemented because the process somehow fails to localize some of the variables upon installation. Still, this provides a way to do it upon installation time, or to name the system something other than the fan speed, like Michael Neisman talked about back at Ignite 2016. 3958. In the domain tab, this shows all the stuff pertinent for the domain, OU, and networking type stuff. There's an area for logging into Active Directory, but that's just pulling information from the Bootstrap INI or custom settings to INI files. 40 minutes. In the control tab, I made it rather apparent that the utility is meant to transfer systems and profiles around, whether it is virtualizing a system or devirtualizing a system. Devirtualization is the process of taking a virtualized system and turning it into a real system. This is the exact opposite of P2V, and it is difficult to do because of the potential issues that may arise. Still, I've done it plenty of times, albeit manually. Once all of these things are acceptable, clicking the Start button kickstarts the installation process. 4014. The installation process takes from 4014 to 13820 as it goes through DISM on a 10.xml and sysprep and OOBE before it gets to the Windows desktop, and the network connection panel notification pops up. A little bit more PowerShell code to get this right there. 58 minutes and 6 seconds is a pretty long time. The only reason it takes that long is because of the age of the system, the Dell PowerEdge R410, and also the fact that the process hits a few speed bumps in relation to how the scripts I modified are handling those modifications. This is the main reason why I had to take a step back from further implementing changes to the process, because it is really a long time for the system to realize. But also I lost a few minutes because I forgot to have the process change the virtual machine's boot priority after the first reboot. 13824. Once the desktop appears, I took a few minutes to get back from whatever else I was doing. I think I might have been eating something. At 141, then I started to look through the SMOSD logs in order to figure out what happened, when it happened, why it happened, whether the 7 doors were actually with Snow White at the time they claimed to have been with her, why they were hesitant to tell me the truth, whether I could trust the 7 dwarves, and if Snow White was actually just sleeping or if she was gone. Once you suspect that 7 dwarves may have killed Snow White, they start to look like they're not very innocent after all. Nah. Look, I'm kidding about the 7 dwarves. They were not involved in this process. Anyway, the script install FightingEntropy was in fact transferred over to the system. However, it failed to launch because of something I didn't configure correctly in the PSD scripts. 143.16. So then I decided to install the module by utilizing the same installation string as in the beginning when I used the custom function flush module. After installing the module, I didn't really accomplish much except to load the module into memory and play around with the features that have since been antiquated. The connection to the share was effectively lost, unless it wasn't. I just didn't invoke get SMB or mapping or connection or whatever it's called, which prevented the module from being able to load the information in the dskey.csv file, and as such, I decided to end the video. Conclusion. This video is almost a couple of years old, and for what it's worth, I managed to orchestrate a lot of work that required some planning ahead in order to compartmentalize the things I've continued to work on over the last 2 years. Here's a video of what I had last October, October 28, 2022, FightingEntropy 2022.10.1. There's the YouTube link, and then here's the most recent version of Get Viper Bomb that makes extensive use of the new module controller, 8/17/2023, Get Viper Bomb 2023.8.0. There's the YouTube link right there. I don't know if a lot of people like the music in that. It's by August Burns Red. I don't know. At some point I'll be demonstrating things in a similar manner to what I did in this particular video. I made a lot of design choices, structural choices, different structural choices, which managed the downloading the file and then installing it and validating it and being able to do a whole bunch of stuff that I talked about earlier in this document. Anyway, that is going to be the end of the video. So if you liked what you saw, feel free to like, comment, or subscribe, and thanks for watching.